Namaste everyone. In this video we will be doing the derivation for the formula of parallel axis theorem. First let us understand what is parallel axis theorem. Let us say we have an irregular shaped object over here with a centroid located at this point. The axis passing through the centroid is called as centroidal x-axis. Let us say we have another axis here, axis 1 1, which is parallel to our centroidal x-axis. The parallel axis theorem helps us to find the value of moment of inertia about this axis 1 1 when the moment of inertia about the centroidal axis is known, or vice versa. So let us find the relation between these two. So first let me define the value of Ix. For that, I will have to assume a small elemental area dA that is located at a distance of y from our x-axis. Now, according to the definition of moment of inertia, Ix is defined as integration of y square dA. Now, we are interested in finding the relation of Ix with moment of inertia about I11 axis. So that is I1. And if we want to put the definition of I1, we will have to know the distance between the two axes as well. Let us say that distance is constant and is d equal to d. So when we put the definition of moment of inertia, we get y plus d as the total distance, square of that multiplied with dA. When we open the brackets here, we get y square plus 2dy plus d square inside the bracket and dA term here. Let's distribute this integration sign to all the terms inside. So we get integration of y square dA as the first term. 2d is constant, so it will come out, and integration of y dA is left here, plus d square is constant again, and we get integration of dA. Now according to the definition over here, we know that integration y square dA is nothing but Ix. For this term, we will be using the definition of centroid. We know the formula for centroid is integration y dA divided by integration dA. Now because the centroid is located on the x-axis itself, the y bar value will be 0 for us in this particular case, and hence when we transfer this over to the other side, that as well becomes 0. So that implies that integration y dA is equal to 0, especially when the centroid is located on the x-axis itself. This, when we substitute here, we get 2d times 0 plus d square as it is, and integration of dA gives us the total area A. So now rewriting this in properly arranged manner, we get I1 equals Ix plus AD square. So this relation is called as parallel axis theorem, and it gives us a relation between any two parallel axes. One of them of course has to be the centroidal axis and the other any arbitrary axis.